Are you saying you tried them out first, or I forgot the story?
I forgot the story. Oh, I tried them a long time ago, but I'm embarrassing now. Just can't find it if I did them now.
It's fine. It's fine. Okay, so the big idea with all analytical geometry questions, I mean, just the word, just the title of the topic, analytical, was supposed to analyze analytical geometry. So just like some of the examples we went through, depending on the sketch you're given, right? The sketch needs to help us to get the does. It says here, a semicircle with center O is given. ON and OM are chords. Yeah, so this is kind of off because a chord, okay, wait, no. Maybe they mean that if it was a full circle, ON, let's not overcomplicate it. They said here, ON and OM are chords of the circle with the equation of line ON equal to this. The equation of OM is equal to this. So we've always said that what's best to do is if you have equations of circles, right? I mean, equations of straight lines, it's always best to just have y as the subject of the formula, you see. So here, y as the subject of the formula, you have -3/2x. And then for the other equation, you have 3y equal to 2x, right? Meaning if you divide by 3 on both sides, you have 2/3x, like that. You see? Now, the fortunate thing is, I mean, if you look at this, at these two, it's not a coincidence that the two gradients, you see, this is just the numbers swapped around, and this has a negative, whereas this has a positive. You see, it's just like how the gradient of one line times the gradient of the other line, it's always going to equal to -1. And if you have one gradient as a fraction, to get the other gradient of the line that it is perpendicular to, you always just flip over the fraction and change the sign. I think most people are familiar with that way of thinking. But then before we even ask our questions, we can't even dive to the questions. The first one, it's not a coincidence. It says, state why we may conclude that these are perpendicular. So you can already see why we can state they're perpendicular, right?
Yes.
Yeah, because of the two gradients. So you can already see here, the gradient of one line multiplied by the gradient of the other line. If you put that in the equation, the left side is equal to the right-hand side, you see. Therefore, left-hand side is equal to the right-hand side, see. Therefore, OM is perpendicular to ON. Good marks, right?
Wait, when you're concluding for the right side or the left side, right? Is it fine to say MON equals to MOM?
If you're doing what?
Like concluding it, right? Instead of saying left hand side equals to right hand side, or the other one at the bottom, is it okay to say MON is equals to, oh sorry, let me repeat properly. Gradient MON equals to gradient MOM.
Well, remember the gradients are not equal. The gradients, if you multiply them, they equal to -1. That's what we're supposed to show.
Also, if I put -1 after that.
If you put -1?
Yeah, like MOM equals to MOM equals to -1.
Oh, remember when you say MON, you're talking about the angle. Because remember, we're supposed to state why we may conclude that ON is perpendicular to OM. So the fact that they're perpendicular, it's just a matter of showing that this is a 90-degree angle. And the one way to do it is to show that the one gradient, if you take the other gradient and you multiply them, they are going to equal to -1. So that's why we just showed that if you multiply them, they equate to -1.
Okay.
So you don't even have to write this here. Not even necessary. It's just being extra, really.
All right.
So, so for the next question, determine the angle of inclination of line OM. So remember, anytime you work out an angle of inclination, it's always the angle with the x-axis. Meaning you're gonna do this. This is the angle they want. Anytime you need to get an angle of inclination, you're always gonna use your tan formula, and you always get a reference angle. And then from there, you can like just observe and see what the angle is. So tan, your angle of inclination, let's just name it theta. Or tan any, or let's just say tan theta is equal to m, right? Normally what I prefer doing is, it's easier to just say stuff like tan, or this is weird, but it's easier to just say stuff like tan with the reference angle is equal to m. Wait, what? Yeah, m, the gradient. What?
Oh, I have another question. You see the circle, right? Since you say that's the inclination, what if the angle of inclination? What if the circle was flipped over? Then what would be the angle of inclination? Will it be by the O or?
Wait, so the fortunate thing is anytime they're going to ask for an angle of inclination, it has to be an angle with the x-axis, and it always has to be you going anti-clockwise. So if you had, let's say, a portion of the circle down here, they cannot, and the top was like gone, you would not necessarily have been, they would, depending on the question they would ask, it would need to be like of a different nature. And then us working it out, we would use whatever it is that we can use based on the question.
Okay, so let me repeat again what you said. So we should always do from the x-axis going anti-clockwise.
Yep.
Right. Okay.
Yeah. So that's the idea. So here now, if we need our reference angle to like then work out the, what you may call the angle of inclination, the first thing is, okay, the gradient of OM, we know it is, which one is it? The one for OM is this side. So let me put OM here. This is the line for OM with the positive gradient. So the gradient is like 2/3. So we know here 2/3 tan the reference angle. You see. So your reference angle here, you're gonna say shift tan with negative 2/3. No, shift tan with the shift tan 2/3. So in the calculator, see what we get there. Shift tan 2/3.
33,69.
Yeah. Of which this as a reference angle, I mean, like, we can see how it's definitely the angle we're looking for. You see, because remember, English and math, they work hand in hand. You see, it's a reference angle. You're supposed to use it as a point of reference to see what this angle is. And just looking at this, you see it's an acute angle. So definitely 33.67 as the angle there is definitely valid. So here, angle of inclination, therefore, angle of inclination is equal to 33.69 degrees. You see?
Oh, okay.
Yeah. So the reason I'm mentioning that is, before we look at question 3, if they had asked for the angle of inclination of ON, then they would be asking for this angle. You see, if they're asking for the angle of inclination of ON, this is what we would do. Let's just rule this up here. So let's say here.
Oh, wait, are we gonna minus it from 180 degrees?
Well, funny enough, if we wanted to get this red, we could easily say that 33.69 plus 90, and then we're done. But then say we maybe did not know that this is 90, then we would need to work it all out together, you see.
Oh, okay.
And the other thing is, you see, angle of inclination always comes from the x-axis going anti-clockwise. That's why it's starting from here going all the way like that. You see, if I want that angle of inclination, it's the angle of inclination of ON. So what we already know is that it is 90 plus 33.69. This we know, right? But then what we're saying is, say we did not know that that portion was a 90. What would we do? So what we know is we're trying to work towards 123.69. This is our answer as the angle of inclination. Like we know it. But I'm saying, say we didn't know that this is 90. To get our angle of inclination, we would do exactly what we wrote up here. Tan reference angle, tan the reference angle is equal to the gradient of ON, of which the gradient of ON, we know it's -3/2. As we can see here, -3/2. So here we would have tan reference angle. Whenever we get the reference angle, remember we always, but you know what, I think, yeah, it's kind of crazy when we write things the way we're writing it. But anyways, your reference angle, right, is always going to be, you take this value and you what you may call, you always work with it as a positive number, 3/2, you see. And the other thing is also, you're not necessarily obligated to write reference angle here. You know, some people may even look at it as weird, you know, so we might as well even just stick to what is normal and what most people will like, and just do what we gotta do. So, but here though, I mean, here I would easily write reference angle, you know, but maybe right at the top, right at the beginning here, we could just leave that out for now, so that we don't make enemies unnecessarily, you know, because hey, it's not necessary. So here, reference angle is going to be shift tan 3/2. Now, if you look nicely, your reference angle is 56.31. And then you can see why it's called a reference. It's supposed to help you work out the actual thing. You're supposed to use it as a point of reference, because technically the 56.31 that we're getting is this acute angle there. You see, because the angle is 56.31.
Oh, I know about this. Now, okay,
Yeah.
I have a question now. So if I do leave it as a negative, do I lose marks?
Well, if you leave it as negative, you're gonna get, let's actually put it in a calculator so that you see what we get. If you left the number as a negative, right? If you put it in your calculator, you're gonna see the answer you get there is -56 point something. You see, of which now you could just work with that and just use it as a positive value and remove it from 180 to get the rest of it, to get this thing here. You see. But as mentioned, I mean, like, you might as well just do what won't give you problems.
Okay.
Yeah. So that angle there, we can then say, therefore, angle of inclination is equal to 180 minus the 56.31, because I mean, like, you're just supposed to use it as a point of reference, you know, of which between the two sides, this is the side that's the acute angle. So 180 minus the 56.31, I mean, you're definitely going to get
123.69.
Yeah, you see, which is what we were expecting anyways.
Yes.
From our question. Cool.
Yes, I understand.
So with what we have done now, they're asking for the gradient of mn. So there's n and m there. What we already know is that this is a 90-degree angle. So them asking for this gradient, quite interesting. Quite an interesting question. All right. Yeah, let's maybe even make it its own tutorial.
I think this is where I struggled. So, yeah.